Welcome to another episode of Today in Space, and we're back for a People of Space segment where we get to talk to people who are in the industry, actually making it happen, whether directly, indirectly, whatever it is. These are the people behind the scenes that are making all the things that are happening in the industry possible. And today, we are very excited to talk with Atomic-6 President and CEO Trevor Smith. Welcome.
Thanks, man. Happy to be here.
Yeah, it's really good to have you.
I'm changing over to founder and CEO because it feels better than president and CEO. President just seems too formal.
Well, one of my questions for you was going to be what is a president? What is your role at Atomic-6? And what does that mean for everyday people?
So I would say mine is chief storyteller and incentive alignment.
Ooh, I love that answer.
Those are sort of my two skill sets.
Because how important is incentive for a business to achieve its goals?
Look, if you can't get people behind what you're doing, if you can't get them incentivized to do something and you can't align those reasons, you can't get anything done, right? You can't get a contract signed. Why would you sign a contract with a company that you both aren't aligned on what you're trying to achieve, right?
Man, I love what you're saying. I wish more people paid attention to it.
Look, we're all humans, and so at the base of it, we are, business oriented. We're a little bit selfish, call it, and we want to achieve our own goals. So, Alex, you have a goal, and I have a goal. So I need to find out, as the chief storyteller and CEO, I need to find out what drives you and what motivates you and what you're trying to achieve, and then try and match that with what I selfishly would like to achieve as well, which is incentive alignment. And that's how you get everybody to the table.
Yeah, it's a win-win-win, right?
Yeah.
Yeah. No, that's great. And the reason I really loved it was because I think so often these roles and incentives in particular become so static over time, and they don't adjust to what the current thing is. Do you find, I'm sure with your storytelling, you're doing a lot of adjusting to whatever the daily narrative is, or, if the business changes, you have to change the story slightly.
Yeah. Lots on that for sure.
Yes. Yes. Well, very cool. Well, it's great to have you. We usually start with the origin story of every guest here. So please tell us about your STEM origin story, but really how you got to where you are today. How did that build? Where did the first inspirations come from? Please.
Yeah, well, not STEM by background, which is,
Awesome.
a sort of unique background. I grew up on a farm outside of Memphis in Northwest Mississippi. Went to the University of Mississippi, or as we say it, Mississippi, Ole Miss.
Yes.
My mom would be proud if I said it that way. And I got a degree in commercial real estate, of all things.
Mm,
Direct line of sight for a defense founder. And so I actually moved to Atlanta in 2010 and was a commercial real estate broker and
mm.
did that for 6 years. So had the entrepreneurial bug from high school days, right? I started
Right.
my own car washing service and all this stuff. And but as a commercial real estate broker, my role was to sort of eat what you kill, right? So it's
Right.
very entrepreneurial in that respect. But it wasn't really building anything that I thought mattered to humanity, right? To speak on a very
Mm,
high level. It was very transactional. And yes, you can help companies and they relocate, but the brokers might say, "Oh, I'm the best broker in town." I'm like, plus or minus 10%, we're all kind of good,
yeah.
right? There was no super distinguishing thing.
Mm,
And so I wanted to find something that one, personally was passionate about, which my background, I grew up racing motorcycles and
cool.
doing all things that go fast, which, sort of influences the podcast that we've talked about that I do a
Mm,
little bit. So we'll jump into that in a minute. But yeah, I met my co-founder, Blake. He was a mechanical engineer, or is a mechanical engineer, and he had his own machine shop. You're familiar with those.
yep.
And he said, "Hey man, I need a warehouse." And I was like, "Great, I'm a real estate broker. Let me help you out." And he ended up selling his company to a composite wheel company,
Mm,
and they wanted to manufacture automotive wheels for the racing segment, right? So
right.
Lamborghinis and Ferraris, and they needed some warehouse. So I got to meet the team there, and they said, "Man, you seem like a really good sales guy. Would you come do sales for us?" And I was like, "Wait, I get to sell carbon fiber wheels to race car owners?
Yeah,
This
that's it.
sounds like a dream job." So I started diving into composites, right? With no like science or engineering background, but I think, Alex, people can quickly learn things, like they can soak it in from reading it just in 10 seconds if they're really passionate about it,
Yes.
right? Like if someone gives you a lecture on insert something you're not excited about, you're not going to remember anything.
Yep.
But if someone says, "Hey, here's how Starship worked on the first launch," you're going to soak most of that in because you're passionate about it, right?
Yep. Yep.
So, being passionate about the topic, I really dove in and spent all my extra time trying to learn about composites. And so, skipping some details, the offer fell through, but I was really excited about
Mm.
composites. So, I got out of real estate
Mhm.
and I started a startup to fund my other startup. My wife thought I was crazy, as most
Yeah.
significant others
Yeah. Yeah.
would, thus the laugh. Startups typically fail 90+% anyway, and this was like risk on top of risk.
Uh-huh.
And so, started a commercial LED lighting company,
Oh.
leveraging my commercial real estate Rolodex to go sell lights, LED lights, right? I didn't know anything about the lighting industry, but with the finance background, it's really just learning what's the ROI. Going
Mm.
back to incentives, like why would you buy this LED light? Well, you want to buy down your operating costs.
Right.
So learn the cash flow, sold a lot of lights, actually made more in lighting than I did in real estate, ironically.
Wow.
Um, and then put every dollar I made into Atomic-6. So
Wow.
use that company to fund the initial sort of bootstrapping for the first 3 years of Atomic-6.
Wow.
Yeah. Um,
That's incredible.
do you want me to keep going or do you want me to pause there?
So I want to pause there real
Yeah.
quick just because you made me laugh so hard because that's definitely the situation that I'm starting over here. So I love hearing it from your perspective because there's a reality to business, right? Of making things happen. And I love how your unique background, like I went to school for aerospace engineering, but I didn't do that well because I was only super passionate about like 40% of the classes. I could do
Yeah.
spacecraft dynamics and plot you a mission to Mars in Excel, but if you asked me differentials, I'd get a 30 on the test. Like I'm just being
Yeah.
completely honest. Like it those things were not the things. Once I figured out why I'm learning this, I could learn it. But as soon as you took it out, I was like, I can't do this right now.
Yeah. Yeah.
So I'm so glad that you're in this, and I think the industry needs more of that balance of the book learning, the hands-on learning, and then just I'm brand new to this and I learned it myself.
Well, it's because of the passion. I was
Yeah.
soaked it up so easily because I was so excited about it. Uh, but yeah, that's sort of
Cool.
like the first 3 years and how we sort of started in 2018 on
Mm.
April 1st, not as a full April Fool's joke. Literally started on April 1st, both companies. Um,
Wow.
yeah, so I can dive into the early days of Atomic-6, or where would you like to
Please.
go from
Yeah,
here?
I'd love to hear the early days because I think that's really important. We've got so many people in the STEM fields right now that are out of a job or looking for a new job, and I think hearing about those, I think there's a lot of companies that are starting today or who have started in the last few years that will be these places they want to go. So I want to give people a taste of what the early days are like.
Sure. So we were in the business of making high performance composites.
Mm,
And because we didn't have a large bank account and didn't quite know what to do, we're like, okay, we'll go consult. We'll tell a
mm,
company how to make these unique composite structures to improve their vehicles.
mm.
And the first meeting we ever had was with Mickey Truck Bodies, the largest not boxcar, truck body manufacturer in North America.
Wow.
We got our LLC 24 hours before the meeting because we had to have an LLC in order to actually have the meeting.
Wow.
So drove up to North Carolina, had the meeting, and we're like, hey, we think we could get you started, $5 million. We can help you set up your own line. Quickly learned that consulting was not going to be the business. Uh, they're like, they looked at us, we didn't have an office or anything, and they're like, you want us to spend $5 million on an autoclave to go make some composites on this thing that you think might work for us.
Mm,
And we're like, okay, this clearly isn't going to work. We got to go build this ourselves. Like
cool.
drove home to Atlanta, and we're like, we got to go build this ourselves. But the thought behind the value to the customer was there, and the thought was, what happens with these trucks is they weigh out before they cube out. meaning
Mm.
they've hit their weight maximum before they've, hit the volume capacity inside that
Oh,
truck. Just
so
like
the
a rocket
truck's too heavy.
right? Just like a rocket ship, are you mass optimized or are you
Mm.
mass constrained or volume constrained? Well, in this case, they were mass constrained and not volume constrained.
Right.
So if we can lower the mass of the vehicle, we could change that constraint over to the volume side.
Mm.
So there was definitely an ROI there, but no one was willing to take a bet on us, so we had to go do it ourselves.
Yeah.
Uh, the next iteration was auto haulers.
Mm.
So, you look at vehicles that are, taking cars and trucks down the road to a dealership, they typically are not full because the
Mm.
vehicles today, especially electric vehicles, are becoming heavier and heavier with those batteries, right? So
Oh, right.
they also were hitting their weight limit before they could hit their volume constraint. And so we're like, all right, we'll go look at auto haulers. Our first conference we ever sponsored was an auto hauler conference. Uh,
Wow.
and I met the two biggest auto hauler manufacturers in the world. One of them is here in Georgia. One of them actually moved to Alabama. But um, same story there. Just lots of regulatory hurdles because it's, Department of Transportation over the road and just
Mm.
real tricky.
Right.
Uh, so we moved on to even more regulatory hurdles. We met with we met with Trinity Rail, which is the largest rail car manufacturer in North America. They're out of
Oh.
Dallas, Texas. And we looked at the truck sets, which is, the thing that holds the wheels on the rail. Super,
Mm.
super heavy. And there's actually precedent for composite truck sets around the world. They've been built before.
Mm.
And so we're looking at our competition, and the competition, all four of them have been started in the early 1800s. And
Wow.
we're like, okay, so there's probably some room for innovation. Um, so anyway, we got through it. The ROI was crazy. It was something like 2 years on a 50-year truck set. So the money was there,
Wow.
but Trinity was concerned about the regulatory hurdles and just getting this new, material set on rails, right?
Yeah.
When you have a train wreck, it can be considered like a domestic terrorism
Yeah.
if like it's a big deal. So
Yeah.
um, pivoted away from that very heavy regulatory hurdle. So going through these iterations, all through that, it's all about payload and range,
Mm.
right? So, okay, we can increase payload and range. If you can make the highest performing composites on planet Earth, who really has to have that? That's going to be people in the extreme demanding environments.
Right.
So fast forward to our first SBIR contract, which is the DoD's way of investing in new development for the Department of Defense. We got a contract, a phase one for like 75 grand with the United States Space Force. And that is what kicked us off into the defense trajectory.
Wow.
So I'll pause there, but that's sort of the kickstart in 2021. Yeah.
That is so cool. I love the jumping from niche and really application to application. So from the 3D printing world as an application engineer, this is how I think about things is where do you find the part and how do you find the ROI for it? So I love that. Uh, I wanted to touch on a composite because composites are such a really amazing thing to manufacture something with. Extremely light, extremely stiff, but also very expensive to make. And the level of quality and handling that you need to have with those composites is like next level. On top of, can you verify the composite was made with no voids or below the limit of voids? Um, could you tell me more about that? I mean, I'm deep in composites, but I'd love to hear how you think about them.
Yeah, I'll actually use the example leading into our first real
Perfect.
opportunity. So we got an opportunity with Lockheed Martin Skunk Works,
Mm,
their
so cool.
special operations division. I think they're now called Advanced Development Technology Group or something like that, but it's still Skunk Works.
It's always skunkworks. Yeah.
So they said, can you just make us a simple flat panel, just a flat piece of carbon fiber, and we'd love to get some lab testing on it. So
Mm,
you brought up void. That is really important. So void or air, for in layman's terms. So you have three sort of things when you make a composite. You have the fiber, carbon fiber typically, the resin, which is the glue, and then void content or the air, right? So you want to get the air out because that causes cracks, delamination, propagation, wings fall off of aircraft, you have a
right.
bad day. Right. And you also don't want too much resin in there because then you just have a heavier system.
Right.
You want a high fiber to resin ratio, typically. So lots of fiber, just enough resin to get the job done. So
Mm,
you're really relying on the fiber for doing all the heavy lifting, and then the resin is just sort of holding it all together.
right.
So we make a flat panel. I'm not an engineer by background, and my co-founder has a full-time job during this period. And
It's
so I said,
amazing.
yeah. So I said, I'll figure this out on my own. I'll fund it. You just tell me how to do it, and I'll learn. Um, I borrowed, begged, and pleaded my way into a local facility that happened to have a very unique autoclave. So
Oh,
our process, just to back up 2 seconds, we use an autoclave, which is a pressurized oven. Essentially can be a bomb if you don't operate it properly. Like literally, people have died because these things
yeah.
have blown up.
Yeah. I
No
mean,
joke.
they even build like blow away walls for
Yeah.
those areas, which is crazy. They're built to blow out a certain way to protect people. Like crazy.
Yeah, doors
Yeah.
doors have blown off and through buildings. Like it's is not a super safe environment.
No.
And I'm like, I'm pretty risk tolerant. I'll figure it out. And so anyway, get into this facility, get our first run going, and the autoclave stops at a certain pressure. And I needed to go 3x that pressure.
Oh wow.
And I've spent, a month of time trying to get this fiber and resin and the
Yeah.
tooling. And I cut the fiber, mixed the resin, prepped everything myself. I watched YouTube for 3 hours trying to learn how to program an autoclave, like right into the
Yeah.
software, how to program it. And I even checked, I emailed the program to an autoclave company and I said, hey, if I put this in, is this going to work? Is this the right input for the right output? And they're like, yeah, how did you do this? And I was like, I watched your YouTube channel. Yep. Um, so anyway, we get there, middle of the run, the pressure stops, and I'm like, oh, this is not good because I need to go 3x higher. So I call the company in California. It's super late. Fortunately, they answered because they have like 24/7 service.
Wow.
And he's like, can you write software code? I'm like, dude, no, I'm a real estate broker. I can't write software code.
Right.
He's like, I'll walk you through this. So middle of the run, this autoclave is pressurized. I'm changing the code in the software, super safe.
So
And
safe.
yeah, press go. And I'm like, oh, it worked. Like the pressure starts going up. And he's like, great, call me later. So pressure goes up and then it gets to a certain point, and I hear the loudest sound I've ever heard in my life. It sounded like a
Mhm.
freight train going by. I thought the autoclave was blowing up. Fortunately, it didn't. It has a thing called a pressure release valve,
Ah.
right? So if it goes to a certain pressure, the valve pops and out comes a lot of
Yep.
noise. It's ear piercing.
Yep.
Um,
Thank God for engineering.
Thank God for engineering. Yeah, yeah, to dummy proof things like that for people like me. But yeah, did that. And so fast forward, get through some of the iterations, fix all the bugs. We end up making a flat panel.
Cool.
Um, and we did some lab testing, and we were less than 0.25% void content. So for aerospace terms, typically 2% is a good mark for void, and we were less than 0.25%. So
Oh my God.
almost no void. Great fiber to resin ratio. And what that led to is pushing the material set to near theoretical limit. So
Wow.
that first panel, and it's a very old video on our YouTube. I'm embarrassed to watch it, but we were
Oh, I'm gonna
within,
watch it now.
yeah, you should. We were within 2% of the theoretical limit for that material set. And so the high water mark was 80, 85%, and we were sitting at 98. And like I did that as not an engineer. We had a unique tool set that allows us to do these things. So it was like, how in the world did you do this?
Uh-huh.
And I was like, I think we have something now. I don't know where to point it, but I think we have something unique. So at that point, we raised our first round in 2021. So
Wow.
just backing up to like the technology that started the company, I call it a glorified muffin pan because everybody knows what a muffin pan is. But it's a mold, right? And so we
Yeah.
have a very unique mold that manipulates that void content, fiber, and resin in a unique manner, pushing it towards its theoretical limit. And so it's agnostic to the raw material inputs. So if
Mm.
you look at our website, we do ballistics, hypersonics, space. So we can do any sort of composite material set, pushing it to that theoretical limit, which
Wow.
allows us to do anything we want. But going back to that incentive alignment, you want to go towards those extreme and demanding environments.
Hmm.
Yeah.
Well, and you did the thing that most people never even accomplish with a with a fully funded company, which is your product was next level in its quality. Like being on the engineering side of things and having built molds and done composite like vacuum mold transfer stuff, like that's insane. That level of void content is people that write the equations for composites dream of a composite performing at that level. And then you guys just put it together, but like it really says a lot to not overthinking it and staying focused on just like what are you doing? Like not all the things you could do, which I think engineers get caught up in a lot. But like what can you actually do? And you guys did it. So like that's incredible. I wanted to say that as someone
Yeah,
that's
thank
worked with
you.
composites.
Thank you.
Yeah. Okay, so tell me more about the kind of parts from what you can. I know you have some stuff you want to show us too. Let's slide into that because I'd love to hear more.
Yeah, I think the breadth of what we are working on is pretty unique. There are some structures that I cannot show you that have been built for unmanned fighter jets. So think like an F-35 without
Wow.
a pilot.
Wow.
So it's called a Group 5 unmanned combat aerial vehicle. So we built the center wing bulkhead, which is the piece that connects the wings to the fuselage.
Wow.
Uh, arguably the most
Critical. Yeah.
arguably the most critical, right? The wings fall
Yeah.
off, you're done. We actually did that with a phase two with the Air Force Research Lab. So that was one of the more
Mm,
fun ones, more challenging. And we did two different bulkheads for two of the primes.
wow.
We are currently under contract to build a hypersonic radome. A radome, if
What's
you don't
yeah,
know,
I
yeah.
don't.
So when you get on like a commercial airliner,
Mm.
the little bubble that's on top of the fuselage,
Oh yeah.
that is the radome. It protects the communication systems from the outside environment. So
Ah.
on a commercial jet, cool, comms get it through, not super harsh environment. But Hermeus, if you've heard of them,
Mm.
yeah, you've heard of them. They're here in Atlanta and they're building hypersonic aircraft. And so they had a need for a radome,
Wow.
but not just any radome, a radome that would survive the hypersonic environment.
All that compressible flow stuff. Yeah.
Yeah. And so going to the incentive alignment, I wanted Hermeus as a customer. Hermeus wanted a hypersonic radome. And the Air Force, I called them and I said, would you be interested in a radome specifically built for this Hermeus aircraft that you're already funding? So
Mm.
check all that. Hermeus
Incentive. Yeah.
incentive alignment, right?
Yeah.
And so I put Hermeus and the Air Force together and we sat in the middle and we're building out that radome now.
Wow.
Not that they need thousands of those, but that's just an example of great
Yeah.
incentive alignment.
Absolutely. Yeah. And to your credit, you're the one in the middle of that, bridging that conversation. Yeah.
So the cool stuff that we are doing in space, let me pull this up here. Um, I'll caveat this. So a little background. In space, things move really fast. You
Mm.
know, space debris, as they say. There's a thing called Kessler syndrome where you have one satellite hits another satellite, causes thousands of more debris. That debris hits other debris, causing, this snowball effect,
Yeah.
right? Not a good situation.
Mm-mm.
I actually
Dark
got to talk
skies, if you will.
dark skies,
Yeah.
yeah. I actually called Don Kessler a few weeks ago and I spoke to him, like the
Oh,
man, the myth,
cool.
Don
That's so
Kessler.
cool.
Yeah. It was cool. His wife answered and she was like yelling across the house, Don, come here. Um, so anyway, he might come to our first launch for this product that we call Space Armor. So
Yeah.
the International Space Station is protected from micrometeorite and orbital debris, MMOD, or just space debris for short. That debris in low Earth orbit is moving around 7.2, 7.5 kilometers per second, which is Mach 21 or 17,000 miles an hour.
Yeah.
Yeah, very, very fast bullets. So they use what's called a Whipple shield designed by Fred Whipple in the late 1940s. That's what's been protecting essentially the ISS today. So we met with Space Systems Command, which is a component of the United States Space Force, and they said we would like to see a new space debris shield developed.
Mm.
So we decided to submit for a direct phase two. We got awarded it, and we built the thinnest, lightest, all composite debris shield that
Wow.
Space Force had ever seen. So that got us that contract, a tactical funding increase contract, which is a follow on from the phase two to get it through space qualification. So all that leading up, I will now show you a cool video that was filmed at Texas A&M's Hypervelocity Impact Lab, where they're shooting a 3 millimeter aluminum ball, so think like a BB,
Cool.
at Mach 21 out of a gun barrel going from 0 to 17,000 miles an hour in about 16 feet. And the G forces on that ball are 1.3 million.
Oh,
Yeah,
oh my God.
it moves fast. So let's do this screen share here real quick. All right. This is on our website too, if anybody wants to see it. So can you see my screen?
I can.
Okay, so on the left side, you'll see space armor, and on the right side, you'll see a monolithic block of aluminum,
Mm,
which is the standard thickness NASA says for a 3 millimeter impact. And I want you to really pay close attention to what happens after the impact and
okay.
the debris coming out of both tests.
Okay. Oh, wow.
Do you notice any difference?
Yeah, the people on the inside of the aluminum structure are screwed. That's for sure. The space armor, I mean, I don't see anything on the right side of that. Maybe some heat, if that's heat.
That's just the infrared camera picking up.
Yeah,
Yeah. So that is a very
that's
unique structure.
crazy.
So there's no secondary debris creation with this. So I brought up the Kessler syndrome because of this. So
Mm,
this was actually like not a planned thing. We saw this during testing where basically just gas and particulate came out of our shield, where when the metal shield got hit, thousands of pieces of debris come out moving super fast. That video was shot at 1 million frames per second
oh my God.
just to give you an idea of how fast this stuff's going. So you can imagine, even with this metallic protection, you're still creating more debris. And as you mentioned on the backside, your satellite, your astronaut, they're still getting some debris coming in, right?
Right.
I don't want to be standing behind that. I might stand behind space armor, but
Yeah,
I
based on
can't
that, absolutely. Yeah.
I can't survive in the vacuum of space, so I can't do it. But
Yeah.
uh, it's a really unique shield. I'll hold it up here. So this one here. This was hit. This impact here, you can see this impact. This is
Yeah.
the 3 millimeter impact. And the
Wow.
backside, there was no deformation. This hole was just a mounting hole. But yeah,
Yeah.
there's no deformation on the back. It's super lightweight,
So light. Yeah.
much lighter than the aluminum counterpart. And the
Hmm.
bigger kicker, the Whipple shields, they use multiple plates of aluminum
Mm.
and basically, stagger them 1.5, 2 inches apart. And so a 3 millimeter protection Whipple shield looks like 5 or 6 inches deep versus
Mm.
the, half inch to 1 inch thick shield that we have. So lots of application in space.
Yeah.
Uh, on top of all that, hit it with directed energy weapons,
Oh my God.
lasers for short.
Wow.
So it's also highly resistant to high power lasers. So that opens up some new concept of operations or ConOps, as we say.
Yeah. Oh, they
Um,
must love you.
well, yes. I'll just I'm not sure what I can say about any of the rest of it, but they're they're intrigued. I'll just say that.
Yeah. Well, and
Um,
and looking forward at like what's going to happen in the future of space here in orbit. I mean, there's a reason the Space Force was created. We have all these satellites that are entering phases of need, they're going to have other spacecraft coming towards them, and the stuff that's up there that's more than 10 years old, I don't think, unless it's a defense satellite, has a lot of defense against anything coming
yeah,
at it. So, yeah, I mean, this seems like the next level. And to have a volume constraint or like a limited volume with extreme armor, I mean, for space, sending that up there, that's huge.
yeah. You could picture that. So because this is formable, we actually could do bulletproofing for astronaut suits. Uh,
Wow.
something on the horizon. Can't announce anything yet, but
Okay.
we are looking into the application of protecting our astronaut suits with
Yeah.
this as well. So all that is super cool.
Yeah.
But the big unlock, the biggest, happened about a month and a half ago.
Mm.
We literally created a new capability for the Space Force.
Wow.
And that's not an understatement. So this debris shield, our ultimate goal was to build a shield with a material set that would allow for radio frequency permeability. Going back to my
Oh.
radome comment. So
Mm.
the Whipple shields, because they're metal, mostly metal, will block all that RF transmission. Ours are not. And so
Mm.
we tested this. We've tested it up to 8 gigahertz so far. We're doing up to 40 gigahertz, but we had a very low percentage loss in the transmission. uh, and it totally fine. Like that percentage loss is very normal for radomes. I'll just
Wow.
leave it at that. I don't
Cool.
remember the specific number, but we literally built the first radome for space. So, so on top of the laser protection and debris protection, and no additional post-impact ejecta, we can now protect comm systems, which are arguably the number one important thing on the
Sure.
spacecraft.
Sure.
So excited to explore that.
Yeah, that sounds really cool. Yeah,
Oh,
and
and
please
yeah,
go
go
ahead.
ahead. We do think, and this is theoretical, because I'm a little bit of a redneck, as they say, growing up on the farm. I was like, I'm gonna shoot this with my Glock, my 9 millimeter. Surely, if this thing can stop a bullet at Mach 21, it'll stop my Glock. The Glock bullet went right through.
Wow.
Do you know why?
Interesting. Is it because it's more like it's got more, I mean, just a bigger bullet?
It was moving too slow.
Oh, so it was failing as the bullet was going through it.
Yeah, the shield. So a great example, if you shoot a supersonic round, a bullet going over this, Mach 20, Mach 1 into water, it goes about 2 feet deep.
Right.
A subsonic round will go like 10 feet deep.
Hmm.
Think like slapping the water versus slowly inserting your hand.
Right.
So our shields don't start working until like Mach 10.
Which
Uh,
is just space. Yeah, for the most
yeah.
part. Yeah.
So we also were like, where could we apply this terrestrially? you know, this isn't going to stop a 9 millimeter, but what moves fast enough that this could work? So we are going to go test this. We haven't tested it yet. We think it will be protective against small explosives.
Wow.
So
Oh.
explosives come out around 10 kilometers per second, which is a little bit faster than what we've tested. And there's no test facility, hypervelocity facility that can test that speed. So we
Mm,
have to go to an explosive range. Um,
love it.
so like, IEDs, C4, Claymore, all that stuff. Like you saw the Russian airfield recently get lit up
Hmm.
by these small explosives. So we think there's an opportunity terrestrially, a big market for it, where we can protect from these small explosives as well.
Yeah, absolutely. Even, wow. That is a really cool application for that. And a fun day at work. That's going to be a
Oh,
blast.
dude,
Literally.
we we're working with the DoD, and we've got a test facility lined up, and
Wow.
I'm excited to go see this.
Wow. So that, I mean, just thinking about composites, I think composites have had a bad rap of things given was it the Ocean Gate? Was that the name of the
Oh
company?
yeah, I had so
Um,
many people calling me about Ocean
I was
Gate.
gonna say, yeah. I mean, I don't know if you want to say anything about it, but if you did have any words about it, I'd be fine with it.
From what I understand, they failed multiple pressure tests, and they still, swam with it. I'm
Right.
like, why would you do that? Like,
So this is perfect. As someone that works with the composites, like didn't make any sense.
so composites are awesome for that environment if they're made properly. But whatever they didn't pass the pressure test, and
Right.
so why would you jump in? I don't know. That was
Yeah.
a really dumb move.
Yeah.
Pressure vessels are used all throughout space and maritime applications.
Yeah.
And so a lot of the rockets and satellites have what's called composite overwrapped pressure vessels, or CPVs or CVPs. So really, really high pressure tanks, which
Mhm.
work well, but you got to build it for the right environment.
Right. No,
Yeah.
and I think that's from the engineering perspective that when I talk to people about it, like that's it. It's just like you got to respect the composite. Like if it's failing, don't use it. Like get rid
Yeah.
of it. Yeah.
And composites are tougher to do with finite element analysis
Mm,
because there's so many more variables,
right.
right? You get a block of metal, it it does the same thing in all directions.
Hmm.
Fiber, you can change fiber orientations, different directions, different resin systems,
Hmm.
3D woven, 2D woven,
Hmm.
4D stacks. Like there's lots of different things that you can do, and so it's a much tougher modeling and simulation than just doing typical metal.
Yeah. Yeah. And back on the directional weaving, like wasn't it recently in racing, like F1 where they had to change the rules on the fiber orientation on some of like the actual outside of the car and the spoilers because people were getting like extreme performance because of their composites.
So I'm a big F1 fan.
Okay.
Are you talking about the
This is probably
McLaren?
4 years ago.
So the McLaren rear wing was allowing for more deformation, which allowed for more air through it
Right.
without their rear wing folding down with that drag reduction system, DRS, as they say during the race. Is that what you're talking
I
about?
think so.
Yeah.
Yeah. It's just like that's where I love composites, where it's just like, oh my God, like they broke the physics of what's possible for that car just with the fiber orientation. Like I love that stuff. But
I just watched the new F1 movie last night. So and a lot of it was about composite and how they like,
cool.
yeah, it was cool.
Oh, I still gotta watch that. That's on my list. Cool. The space armor is such a cool application just in general for space. And we're in this period of the space industry where we just experienced a decade of like insane progress, privatization and public side of things working together. You've got NASA with the Artemis program, SpaceX, the big leader in the private side of space, as the first lander. Um, where are you seeing the space industry right now? And I guess it would combine with the defense side of things. It feels like there's still a huge momentum in that industry. How are you guys? What's the temperature in the field over there with things?
It's hot.
Yeah.
Like a test stand at SpaceX. It's hot.
Mm,
So I'll give you some numbers. The first problem with space was figuring out launch.
mm,
Arguably, SpaceX has figured that out.
yeah.
My chief operating officer, Christian Carpenter, worked at SpaceX and was on that original team that actually helped design the propulsion system for Starlink,
Mm.
a Hall thruster,
Just yeah. And it just
Hall
came out of
effect
nowhere
system.
one day. It just was just like, excuse me?
Yeah, yeah. So, SpaceX is a logistics company that really built their shuttles to launch their constellations, which is the moneymaker.
Yep.
Um, so 2.5, 3 years ago, the global, don't hold me to these numbers, but the global demand for solar array, uh, if you exclude Starlink,
Mm,
was 2 megawatts of power, like 2 or 3 years ago,
right.
which is like 400 homes. It's not a lot of power, but 2 megawatts of power. It's a lot of power in space, but
Right.
yeah, the global demand was 2 megawatts if you exclude Starlink. Today, which we are super excited about, and we think the biggest bottleneck in the space supply chain is space solar power. Um, the Major General Steve Purdy, who reports to the
Mm,
Pentagon, his number one supply chain priority is space power, meaning like
mm.
solar arrays. So in our pipeline today, our sales pipeline, we have 5 times the entire global demand that existed 3 years ago
Wow.
for solar
Three
arrays.
years. That's crazy.
Yeah. So 10 megawatts of power just in the past 6 months of opportunities that we are actively bidding on. So that has that has led to an explosion of opportunities in space. And so
Mm,
people need more satellites need solar arrays, right?
right.
And so because we're a composite company, we have come up with
Mm.
a very unique redeployable solar array that has gathered a lot of attention.
Yeah.
Happy to jump in and talk about that.
Please do. Yeah, I'll say one thing about just solar power in general in space. Like, I think in the general public, most people just think about like, well, it's got nuclear rods on there. It's like, no, no. The main power source in space is from the sun, and it's from solar panels. Like, that's your core. That's your oil here on Earth.
Yeah,
Like,
that you're either using chemical propulsion and solar
mm,
or just solar.
yeah.
Because small nuclear reactors aren't quite a thing yet. And so if you're running
And
just
rightfully
either,
so.
yeah,
Like, if it blows up on the pad, you've got a real serious problem on your hands.
yeah, yeah. Solar arrays don't explode,
Yeah.
fortunately.
Yeah.
So going back to Christian, our chief operating officer, so he left SpaceX and he had been working on this problem for 20 years. He's like,
Mm,
once launch gets figured out, the next big thing that needs to be figured out is an economical, productized, and scalable solar array system,
mm,
right? So you figured out launch, the biggest, arguably the biggest line item on your bill of materials for a satellite is the solar array,
yeah.
right? Depends on your payload and what you're flying, but generally the solar array is number one, number two, most expensive thing to fly.
Yeah.
So that's the next bottleneck. So Christian joined Atomic-6 to figure out how we can build that scalable, robust, reliable solar array system.
So
Uh,
cool.
so we call it Lightwing. Um,
Mm,
and it is a redeployable solar array. And I'll talk about why redeployability is important.
mm,
Um, but we've done some pretty unique things in the design itself. So let me show you a quick video, and then I'll flash some components of it. So background on this video, this is in our warehouse here at Marietta, Georgia,
mm.
and we built a gravity offloader, which simulates what the system would, see in a zero G environment.
Oh, cool.
So this is our deployment mechanism and array. So this is a 1 kilowatt, 1,000 watt array size. So it's about 15 feet long. And that 1,000 watts is if you were to use silicon-based solar cells,
Okay.
which is a lower efficiency cell versus your gas cells, your gallium arsenide cells, triple
Mm,
junction cells. So if you use gas cells, it would be half the length. But
mm,
the redeployability is really key because you can do lots of different ConOps, concept of operations, and also lower the issues that we typically see with solar array deployment. So the number one reason today for satellite infant mortality rate is the solar array deployment. Like, why do
mm.
satellites die right after they launch?
Right.
Typically, it's a failed deployment because those mechanisms are so complex. They look
Mm.
like a scissor lift, right? So like it's kind of going out like this.
Yeah.
Fancy word is a pantograph. Um, but those are, metal systems that don't like to operate in minus 80 degrees C temperatures. Composites are really good for that.
Yeah.
So I'll show you the system, sort of the subcomponents of the system here. This system is designed to be super lightweight, with as little part count as possible. So
Mm,
I call it a backsheet, but we have our substrate here, and then we have our space hinge flexure, which is
mm.
basically a memory shaped composite
I
hinge.
was gonna ask. Yeah, that's cool.
And then you have space mast, which is a double omega closed cross section deployable mast. So in the video, it rolls up and deploys out just like a tape measure.
Mm.
So if you look at my video, I'll show you, I'm holding up like a 6-inch section of the mast.
Oh, wow.
So you can flatten it and then roll it up, and then it can pop out into that structure.
Oh, wow.
The hinge is actually like one of the more unique things. So if you look at that hinge, I'm holding one up. This is a metal door hinge, just like you have in your office. So it has biaxial loading. It can kind of lock up in either direction. Our hinge only has loading in one direction because it's memory shaped and can deploy out like this. So as that system deploys out, it pulls tension on those back sheets that sit, here and here.
Oh.
So we got rid of the heavy metal. We got rid of the, problematic area. And because we don't need thickness in that substrate for stiffness, we can use a very, very thin substrate or backsheet. So most backsheets are like 1 inch thick sandwich structures,
Mm.
because they need that thickness for stiffness.
Right.
Our, if you look at my video here, this is one of our backsheets here. It's pretty thin,
Mm-hmm.
9,000ths of an inch thick, super flexible and lightweight.
Cool.
So you can get the tension you need from deploying that system out with this hinge that flexes as that system deploys, ultimately leading to the metric that we all care about in space power, which is watts per kilo. So how much power to how much mass,
Mm.
right? So this system is pushing 200 watts per kilo, give or take, depending on the size of the array.
Yeah.
We have versions of this for the lunar and Martian infrastructure that will be pushing 300 watts per kilogram.
Wow.
So this particular system is what has gathered all this, interest from lots of different mega constellations. And so going back to, yes, launch is cheaper. You saw in the Russia-Ukraine war that's going on, Starlink's that don't want to be reliant on Starlink. They want their own system.
Yep.
Or you need broadband connection to, your cell phone. I think cell towers hopefully will be a thing of the past. T-Mobile in the Super Bowl advertised, sat to cell service.
Right.
This is becoming more and more of a thing, and you're looking at thousands of satellites being launched, hundreds, 50 to 100,000 satellites in the next 10 years.
Yep.
So that is where we see the big opportunity in space is really with the power. And so when you think about Atomic-6, think about who do you pay your utility bill to? Con Edison or Duke Energy or
Right.
Georgia Pacific. We want to build out the power grid for space. We
Mm,
want we want to offer that infrastructure. So it's an infrastructure play, and that's what we're going after because we do see this massive opportunity. Again, 5x the global demand
yeah.
3 years ago is now in our sales pipeline. So there's a real
Mm,
need and a real opportunity for these high performance systems that offer that mass trade-off. So when you're looking at a system that's 200 watts per kilo versus 50 watts per kilo, do the quick math if you're launching a few thousand satellites. If you are mass constrained, you could add 3 or 4 more satellites per Falcon 9 launch, which are
hmm.
not cheap, $62 million a pop.
Yep.
Right? So let's say you're launching 4,000 satellites. You can Google some FCC spectrum registrations. You can take a quick guess, but you know, I could save you 18 to 20 Falcon 9 launches over the life of your program, which is a little over $1 billion in launch costs
Yeah.
if you choose to fly our system. On top of that, what's really unique, I went to London earlier this year and I presented both Space Armor and Lightwing to 19 different underwriters
Mm,
who represent the syndicates for Lloyd's of London, writing about 80% of all space insurance premiums. So we have a few letters
wow.
from them. We have a few letters from them saying, once our systems are flight qualled, they are interested in promoting this as a risk mitigant to their customers, right? So you could
Smart.
you could envision a world where, hey, my car has an airbag or a seatbelt. My insurance company is going to give me a lower insurance premium because my vehicle is safer, right? It's very public. There was a large insurance claim last year, $450 million because of a failed solar array deployment. It's that simple, right?
Yeah.
So we can make these systems more robust, more reliable, lighter weight, more redundant. It's just a better place for space.
Yeah. Absolutely. And the thing that you made me think of, and you might have touched on this, so sorry if I'm repeating you, but it's an important point. Like with these systems being lighter, with you not having all of that thickness on the solar arrays, like you can also just get more out of every launch too. Because you've got all of Europe that's gonna want, they saw with the relationship with the US that like NASA could get cut and funding that's been worked on, projects that have been worked on for a decade, like the Mars sample return, is is gone. And now
Yeah,
where are they going to go? So they want to become more independent, which I think is great for
yeah.
everyone. So like having these systems, like I'm sure Europe is trying to figure out all the ways and way to in how to incentivize. I know I talked to people in Germany and in the United Kingdom that are, you know, waiting for working on getting that up and running, you know? So I think technology like yours is going to be super important because if you can get the insurance companies to help free up, like anything to free up launching and getting to space is going to be critical.
So
Move,
I'll throw you a curveball here.
please.
Not it's sort of on topic. Have you given much thought to orbital data centers and how much they've been in the news lately?
I definitely have, and even like orbital refueling, orbital power, like, yeah, I think there's a lot more that can be done that hasn't been. But please.
Yeah, so we made an announcement about 2 months ago. It's our first big space announcement. We have a 6 mission lunar orbit contract with
Ooh,
Sidus Space and Lone Star Data to power the first data centers that will be in lunar orbit.
let's
Super
go.
excited about that. Yeah, very excited about that one. And then
Oh, that's huge.
you look at companies that need to do lunar mining or orbital
Mm.
data centers where they need these large solar array systems.
Mm.
Um, I have something to show you. So I showed you this little bitty 2 inch diameter close cross section. We have built under a phase one with NASA and a commercial customer a 12-inch diameter, much larger system. Um,
Oh,
so this is quite a large piece. Um,
wow.
very flexible. You can flatten it up, roll it out. But let me show you the big. This is just my carry-on. Let me show you the big one. So this system is really designed for lunar infrastructure, lunar mining, powering those systems,
Yeah.
orbital data centers that need those big systems, space-based solar power, all those applications, right? So this is a 33-foot tall deployable mast sitting outside of our warehouse. Um, really excited to build these much, much larger systems. Again, going back to we will be the power grid for space, we're addressing the small systems and the large systems.
What you're showing me is so crazy. Like I I got in trouble in one of my classes. We were playing a mission to Mars, and I was designing things that were not readily available because flight heritage was very important, almost too important when I was in college. I still agree, flight heritage is super important. You've
Yeah.
got to get stuff into space to prove it works, but that doesn't mean we can't build awesome stuff that's not on the market yet. Like I
Yeah.
love that you're doing that, and then people are going to be able to it opens up the design for spacecraft, which is so limited right now. And I think that's
Well,
awesome.
that whole system rolls up into the small box. It's like 2 foot by 1 foot. You can put it in your backpack.
Oh my God, because you can compress it and roll it up.
So we're actually looking at
Oh,
terrestrial applications for over-the-horizon comms for military purposes, right?
right.
You need to pop up an antenna for the next 3 minutes, put it up, do your comms, roll it back down, put it in your backpack, right?
Wow.
Super lightweight system, like 25 pounds.
Yeah.
And we didn't talk about the reason for retractability. So I'll mention that
Mm,
a couple of use cases in ConOps. So you've got Tom Mueller with Impulse Space, right?
mm.
High thrust capability,
Legendary. Yep.
legendary, Mr. Merlin. And then shout out to my buddy Jeff Thornburg over at Portal Space Systems, also very high delta V, high thrust capability. Today's solar arrays would rip off because of the inertia of those thrust systems. So with ours, you can retract the array, press the gas pedal, and then redeploy.
That's great. And then charging can be an optional thing and not a constant. You could fill your
Yeah.
batteries up, make your moves, and then redeploy again.
Yep. If you
Wow.
want to land on a celestial body, the moon, an asteroid, whatever,
You go
bring
with your
your
eyes.
arrays
Yeah.
in, land,
Yeah.
and then redeploy. Uh,
Wow.
if you if you're worried about somebody looking at you, an adversarial spacecraft looking at you, we could retract the arrays, lowering the visual signature of your spacecraft. And you no longer kind of look like a spacecraft, right? So
Yeah.
that's unique in some
It's really
applications.
unique. Yeah.
Threat avoidance. The International Space Station is always having to move around these heavy debris areas. So we're talking to a few space station providers. You'll see in the podcast that we do with Gravitics, a really
Yes.
unique space station. But you'll have to look that up. But they're like, we gotta get through these debris areas. We could retract our arrays, minimizing that debris impact, and then redeploy. Like
Yeah.
the ISS gets hit with this stuff all the time.
Hmm.
Uh, Commander Chris Hadfield, sole Canadian commander of the ISS, he's a friend of mine and he's on our advisory board. I asked him, I said, how often is the ISS getting hit? He goes, it sounds like rain on a tin roof. Like it's
That's
always getting hit,
crazy.
which is scary because when they do spacewalks, that like it's always out there.
Yeah.
I'm surprised we haven't had a major incident because of that.
Yeah,
Now,
that's
you
nuts.
know, you know what RPOD stands for, but rendezvous, proximity operations, and docking. So you mentioned refueling, life
Mhm.
extension, all that. If you have the ability to retract your arrays, it makes docking so much easier, right? Because you're not coming in with these big floppy things. You
Hmm.
can pull them in, dock, and then redeploy. If you're taking high resolution images, retract your arrays, lower the center of gravity and the jitter of the spacecraft.
And you're more
Take your
stable.
take your image and then redeploy. Also, we had
Brilliant.
somebody ask us, like from a GNCC or a GNC perspective, like
Mhm.
if it's tumbling, could we just put one wing out and then like spin the what's it called? What's the circle thing?
Uh, Reaction control.
Reaction wheel. Reaction
Yeah.
wheel. Sorry. Yeah. So like we're looking at opportunities where we could actually help stabilize a satellite that is like tumbling, where we're just sticking one wing out, changing that center of gravity to help the reaction wheel balance the satellite out.
Yeah.
Lots of fun, unique ConOps.
Yeah. Have you guys done any work with cube satellites?
No, we
Okay.
have some opportunities coming up, but these systems, the way we've designed them, tend to be like, they need at least 500 watts for that deployable system to work.
Ah, right. It's the power
But
limit.
our first flight that is booked is Feb 1 of next year, going out of Vandenberg
Oh.
Space Force Base. We made, I call them pop out panels, just
Ooh.
three, sandwich structure panels that will pop out from the spacecraft. They're like
Mm.
100 watts a piece. So we do have that offering, but That's not the the big revenue mega
Sure.
constellation.
Oh
But
no, absolutely. I was thinking more so I've gotten really intrigued with the idea of almost sending like CubeSat scouts out to a place, especially with this is the mining side of things. I
oh
think
yeah,
they're going to start using this. Um, and that could be an interesting way to create a larger structure with just a bunch of cube satellites. You could have different formations, and I don't know. That's where my brain went with that. So that's really cool.
yeah. I mean, making modular spacecraft is going to be a thing, and that's how a lot of the ODCs or orbital data centers are looking at doing it, right? Connecting these smaller nodes in large modular fashion, so you
Hmm.
don't have just one big juicy target, as they like to say. You're more proliferated.
Yeah. No, that's amazing stuff, dude. So, okay, so we're at the hour mark. I
Yeah,
wanted to close up. Was there anything we didn't touch on that you'd like to chat about?
man, we're just having so much fun.
Yeah, I know. I want to do another one.
We're having so much
Totally
fun
should.
and building some unique capabilities. I'm really excited where the industry is going, and yeah, and would love to have you on my podcast if it makes
Absolutely.
sense.
Yeah.
It's called Full Burn, selfish plug.
So
Um,
such a
but
great name.
but going to my racing days, I was like, what's a unique platform I could excite people to come on with me. And so it's called Full Burn, but I usually will go rent an exotic car like a Ferrari, Lamborghini, McLaren, and just drive around with space founders and interview them while we do fun things in fast cars. And that Gravitics episode I mentioned, we actually parked a Lamborghini Huracan inside their space station mock-up and took a big like team photo, and it fit like with plenty of room because it's like a 8 meter diameter station over at Gravitics. So that was a lot of fun.
Cool. Yeah, I would love to be. That sounds like so much fun.
Cool. Love
And
to
I
have you
can't wait
on.
to check it out.
Yeah, thank you.
We usually have people close with like last words for people who are listening, whether they are trying to get into the industry or they're also a founder or someone working and building the next future of space. Any last minute words for folks?
If you're wanting to start a company, I think one of the key characteristics is delusional optimism. That's what I like to call it. Delusional optimism, and I'll give you my definition of it, is where you, Alex, you are convicted on some piece of information that you feel to be true, that the outside world thinks is delusional. And so it's kind of like, insider trading. You've got some really unique information that everybody else thinks is crazy. And you have to be a little bit delusional and always optimistic to make
Mm.
it work. Right. So I think that's a really key thing for a founder to have is that delusional, optimistic capability. Yeah.
I like that you said it's a capability because I do think that's really important and especially if you're doing anything, if you're starting a business, you're doing something that's not normal. So to go the next step and say that you're going to have to do everything that's normal or feel, certain things make you feel shameful because, oh, I'm not part of the group now. Like that's part of the journey of this
Yes.
thing, right?
Totally. And be prepared to run through walls. And then, delusional, right? And then, like, when you go to raise, don't raise on hype, raise on what you've
Mm,
done,
mm,
right? So I bootstrapped the company for 3 years because I didn't want to burn investor dollars trying to find a trajectory for the company.
yeah.
We only did our first raise once we like had something solid and exciting. So don't raise on hype, raise on what you've done, because ultimately what matters is that awesome exit and you as a founder owning a lot more of your company than just 5 or 10% because you've taken on 6 or 7, rounds of funding and been diluted to very little.
Boy, I couldn't agree with that more. Trevor Smith, thank you so much for being on Today in Space podcast. It was an absolute pleasure to speak with you today. Hey, everybody, thanks for hanging around this long. If you're here this far into the episode, you are friggin' amazing. Thank you. I love you. Thanks for being here. As always, if you haven't already, subscribe to the channel. We've got so much that's going out, so much so that it's been hard for me to edit all these episodes from Today in Space to the new 3D printing podcast I have with my friend Matt Guy, Layered Insights, where we talk about 3D printing. Like, if you love the passion that I talk about space with, then you're going to love the passion that both Matt and I are talking about as owners of 3D printing companies, talking about 3D printing and what's awesome about it and all that. But in order to stay up with everything that I'm doing, there's one link to rule them all. It's stan.store/AG3D Labs. And that's where you're going to be able to find everything that we're doing because there's so much going on between both podcasts, Layered Insights, and Today in Space. We've also got our 3D printing company, AG3D Labs, where we are developing 3D printing AI to help people be more successful. We've got a lot of stuff that's coming out. We already have our services that are on that same link where we can help you with your 3D print problem. If you are running a 3D printer, your print failed, and you just need help getting it across the line to do your next thing so that you can solve the problem, that's what we're here for at AG3D Labs. There's that option, and then there's also the choose your 3D printer option. Maybe, especially with the holidays coming up, maybe a loved one or maybe yourself has been looking for a 3D printer, but there's so much out there, you're just not sure what to get. That's exactly what we help. We've been answering that question for years for people, so we're happy to be able to offer that as a service at stan.store/AG3D Labs. And you'll also be able to book an hour with us to ask us anything about 3D printing and AI, separate sessions. Go check out stan.store/AG3